Rogue planets. Rogue planets are planetary mass objects that do not orbit a star directly. These objects have been ejected from the planetary system in which they were formed, or maybe they have never been gravitationally bound to any star or any specific brown dwarfs. NASA is working on a new space telescope that is aimed at locating invisible rogue planets. Of course, as they continue to hunt for these rogue planets, they are hoping to make some amazing discoveries with the Nancy Grace Roman Space Telescope. This is NASA's upcoming observatory, and it is expected to launch in the mid-2020s. This space telescope could reveal a multitude of rogue planets that currently do not orbit any stars in our Milky Way galaxy. These exoplanets, or planets located outside of our solar system, move through the galaxy on their own, and they are not locked in orbits around any stars. Whilst our Earth orbits the Sun, these rogue planets, which could either be planets or exoplanets, are independent of any system. Being able to understand the behavior of rogue planets could open up more information on the formation, evolution, and the disruption of planetary systems. Rogue planets are difficult to locate, and scientists have only located a few rogue planets. The intention of the Roman Space Telescope is that its capabilities will allow it to find and characterize these roaming nomad rogue planets. As our view of the universe has expanded and continues to expand, we have realized that our solar system may be unusual. The Roman Space Telescope will help us to learn more about how we fit in the cosmic scheme of things by studying rogue planets. Take, for instance, if our little rocky planet was just floating freely in space. That's what this mission will help us to understand. The telescope, which is named in honor of the agency's first chief of astronomy, is equipped with a powerful 2.4-meter mirror that will allow it to search for exoplanets. The telescope will stare at the large swaths of the sky and watch for gravitational microlensing events. This is where a planet and its star will pass in front of a background star. Microlensing occurs when the presence of something massive can actually warp space-time, like black holes, but it can also occur around planets. Take, for instance, if a rogue planet is in alignment with a distant star, the light from that star will essentially bend around the planet, resulting in a magnifying effect. Researchers can use the changes in light around the planet to measure the planet's mass. The microlensing signal from a rogue planet will only last between a few hours and a couple of days, and then it will be gone. This means that it is very difficult to observe rogue planets from the Earth, even with the use of multiple telescopes. The Roman Space Telescope, however, will change everything and will help us to assess, examine, observe, and analyze rogue planets. Rogue planets do not emit any light. They have enough heat to be visible in infrared light. Invisible worlds will be visible through the Roman telescope's observations of microlensing events. This field is very important to our understanding, and it is 100 times greater than Hubble's infrared instrument. So therefore, this telescope can observe more of the sky in less time. It will also allow for high contrast imaging of individual nearby exoplanets. The Roman Space Telescope will measure light from 1 billion galaxies and seek to provide information that could answer critical questions about how common planetary arrangements are to our own solar system, as well as how many planets may be able to harbor life. It also has the ability to find rogue planets as small as Mars, which is slightly bigger than half the size of Earth. Planet birth itself is a violent, erratic process. Gas and dust in disks around young stars clump together and gradually grow in size to form planets. However, collisions between objects on grander scales, or even coming too close to another planet in orbit around the star or the star itself, can kick the planet out of its system. Now, this planet would be on its own, very much independent of its star, and according to scientists, these planets are known as rogue planets. It is also possible that lonely planets can form on their own in isolated clouds of gas and dust. The Roman Space Telescope will assist researchers to determine how these planets form by providing information about how many there are, as well as what the masses of these rogue planets are, and they could help us to understand the origin of their story. Researchers continue to use estimates from ground-based telescopes, and these estimates suggest that the Roman Space Telescope could find hundreds of rogue planets, which would help scientists to understand how common they are in our Milky Way galaxy. The telescope's discoveries could reveal that there are actually more rogue planets than there are stars in our galaxy. The Roman Space Telescope will be 10 times more sensitive to rogue planet detection than any other telescopes, and it will search for them across 24,000 light years between our Sun and the center of our Milky Way galaxy. The universe could be teeming with rogue planets, and we may not even be aware of it. We would never find out without undertaking a thorough space-based macrolensing survey mission that our Roman Space Telescope will be undertaking as soon as it is completed. Like, comment, share, and subscribe. Let me know what you think about rogue planets and NASA's investigations.